So these are the ones that have square roots, cubed roots. They could have fourth roots, fifth roots. They could have fractions and your exponent. They all kind of fit underneath this bucket. So when you're solving one of these, what you want to do is get the radical symbol by itself. You're going to try to do that, and if it has a number in front of it, you're going to have to divide both sides by that number because you just want it by itself. And then what you do is you undo it. So if it's a square root, you square. If it's a cubed root, you cube. So you're going to do the reverse operation to undo the symbol. Then you're going to end up with something that's linear or quadratic, and then you solve using our methods for that. And we always have to check our answers because we get what are called extraneous solutions. They're basically extra solutions because whenever you're squaring something, you're taking something that maybe had one solution and now you're creating two solutions. So while I didn't check my answers for any of the polynomial ones, you do need to check your answers for radical equations because you do create solutions that aren't solutions to the original problem. So these take a little more time because you have to check your work. So I'm going to start with one that has a square root. So we need to get the square root by itself, and I have this equal to 0. The easiest way to get the square root by itself is to actually add 2 square root of x to both sides instead of subtracting the 6. And I do that just because I like to have positives on, in front of my variables and stuff. Whoops, I meant to write a plus instead of an equal sign there. So if I subtracted 6, then I just have negatives, and whenever possible, I try to get rid of those so I can have positives. So we have 6 equals 2 times the square root of x. Now I want that x, or the square root of x by itself, so I need to get rid of that 2 in front. That is 2 times the square root of x, so we're going to divide both sides by 2. So 6 divided by 2 is 3. So 3 times the square root of x. Now I need to undo the square root. And so we do this by squaring both sides. And this is a process that's going to result in extra solutions. So 3 squared is 9. So we get 9 is equal to x. Now in this case, we have one solution. So sometimes it's possible to solve and you end up with no solutions if this ended up being an extra solution. So we need to check that x equals 9 actually works in this equation, because if it doesn't, then we have no solution. So these equations actually tend to show up with no solutions much more than other types of equations. So you have to watch out for that, that if you get something that doesn't work, that doesn't necessarily mean you messed up. It could mean there's no solution. So I'm going to check my work, check my answer, just to see if it works or not. So 6 minus 2 times the square root, and then instead of x, I'm going to write 9 equals 0. So the square root of 9 is 3, so this is going to be 6 minus 2 times 3 equals 0. 2 times 3 is 6, so we get 6 minus 6 equals 0, which gives us 0 equals 0. Our answer checks out because we get something that's true. So in this case, we got lucky. We didn't have any extra solutions, and so our solution that we found is the correct answer. So sometimes you get extras. So example here, now we have a cubed root. So this one you're going to have, to undo a cube root, cube your thing. So again, we need to get that cubed root by itself. And so I'm going to do this by adding 3 to both sides. So the cubed root of 12 minus x equal to 3. So in order to undo the cubed root, we're going to cube both sides. So when you cube that, you get what's underneath, 12 minus x, and then 3 to the third power is 27. So we have 12 minus x equals 27. So now you have something linear everything always goes back to a quadratic or linear equation in the end. So now we have a linear equation that we can solve for x. So I'm going to subtract 12 from both sides. And don't forget that negative in front of the x. I see a lot of people drop negatives. It's very important to make sure you include the negative if there's a negative in front. And then 27 minus 12 gives you 15. So then I'm going to divide both sides by -1, which gives me x is equal to -15. Now we need to check our answer. So I need to plug this into our original problem. The cubed root of 12 minus -15 minus 3 equals 0. So 12 minus a -15, that's 12 plus 15, so that gets us back to 27. So the cubed root of 27 minus 3 equals 0. Cubed root of 27 is 3, so we get 3 minus 3 equals 0, which works out to 0 equals 0. So this checks out, and so that is our answer. Now a little tip. When you're looking to see whether you have extra solutions or not, it depends on what's underneath the radical symbol. If you have something linear underneath the radical symbol, you should have one solution. So we had something linear at 12 minus x, that's linear, under the symbol, so we should have one solution. So generally what that means is if you got one solution when you solved, it's going to check out. If somehow when we were solving we ended up with something squared and we ended up with two solutions, then one of those won't check out because it's linear underneath the symbol. The same thing here. So we had just x, so that's linear. So we should have one solution. If we had ended up with more than one, then one of them wouldn't have worked out. I've never actually seen this rule written down anywhere, but I've never had it disproved in all the many times that I've solved. So this is my, I don't want to say that it's a hard and fast rule because I've never actually seen it taught anywhere, and I don't want to teach you guys something that maybe there's one case where it doesn't work out, but I have not seen it disproved. So that's basically a rule of thumb that I use to determine, to double check myself. Okay, it's linear, I should get one solution here. Now the next one here, so this has a rational exponent. It still falls underneath a radical because anything where you're having a fraction in your exponent, those can be rewritten as radical equations. And my guiding rule here still applies. So I have x plus 2 in the parentheses, so we should have one solution here because that's linear. So when you're solving something like this, you need to get the rational exponent by itself. In this case, it's already by itself, so we don't have to do anything extra. And what you want to do is undo by taking it to the power of the reciprocal. So in these cases, you're going to take the reciprocal. You're going to raise it to the reciprocal power. So the exponent is 2/3, so we're going to raise it to the 3/2 power. And that works out because when you multiply those fractions, we have 2/3. And when you multiply your exponents, so it would be times 3/2, we get 6/6, which equals 1. So that's how that cancels out. So I'm left with x plus 2 equals 9 to the 3/2 power. Now we need to simplify 9 to the 3/2. So I, whenever possible, try to separate it out so that I have the fraction part and then I do the numerator there. So I can split the 3/2 to 1/2 times 3. And I'm going to do the 1/2 part. So that 1/2, that means we're taking the square root of 9 because the square root is actually the same thing as a 1/2 power. And I see that I wrote an extra equal sign. That should be x plus 2. So I'm splitting this, so I have 3/2, and I can split that up as two fractions multiplied by each other, and I'm basically splitting them up and then putting ones in the other direction. And 3/1 is just equal to 3. So this is the same thing as 3 times 1/2. And so then what I'm doing is our rule of exponents are that if you have an exponent and then another exponent outside there, you multiply. And so I'm just undoing that process, and I'm doing it specifically so that I have the 1/2 part, the fraction part on the inside, and then the whole number on the outside. So we have this 9 to the 1/2 power, so that's the same thing as taking the square root. So I'm going to take the square root of 9, which gives us 3. So I'm going to have x plus 2 equals 3 to the 3rd power. So then I'm going to do 3 to the 3rd power. You can. Yeah, that you can definitely do that. And if you did that on the left with the x plus 2, it's actually a lot more complicated to solve it that way, so which is why I didn't do that. But you could take this 9 to the 3/2, and you can turn this into 9 cubed and then the square root. That's the same thing. And actually, you're allowed to rearrange those. So you could do 9 squared and then take, and then, whoops, 9 square root, and then cube it. And that's essentially what I'm doing. I'm just writing it as a fraction exponent instead of the square root symbol. So either one of those, you'll get the same answer. I decided to do the square root first because it makes it smaller, because 9 cubed is a giant number, and I'd rather cube something smaller. So we've got x plus 2 equals 3 cubed. So 3 cubed is equal to 27. So I have x plus 2 equals 27. So I'm going to subtract 2 from both sides, which gives us x is equal to 25. Now we do want to check our answer here. This should be the solution because, as I said, we're looking for one solution. We got one answer here, but we should always check. So I'm going to plug that in. So in parentheses, we have x plus 2. So it's going to be 25 plus 2 to the 2/3 power, and we're hoping we're going to get 9 out. So 25 plus 2 is 27. And I'm going to just do 27 2/3 power in my calculator. Because if you just want to make sure that your calculator, that if you're going to do that, you need to put parentheses around the 2/3 to make sure that it's doing it correctly. But you do get 9. So we get 9 equal to 9, which means that our answer does check. So x in this case is 25.